Hey everyone, welcome back. If you're a fifth-year medical student gearing up for Professor Luongo's pharmacology exam, you are in exactly the right place. Today's explainer is a high-yield, purely exam-focused review of pain management and perception. We're going to cut right through the noise and get you exam ready.
Here's our game plan for today. First, defining and classifying pain. Second, altered pain and sensitization. Third, the subjectivity of pain. Fourth, the pathophysiology of chronic pain, and we'll wrap up with a rapid-fire exam review. Let's get to it.
Section 1. Defining and classifying pain. Let's start with the official ISP definition. They define pain as an unpleasant sensory and emotional experience associated with actual or potential tissue damage. Professor Luongo really emphasizes this twofold nature. Pain isn't just nociception, the simple transmission of a noxious stimulus. It's fundamentally a subjective, emotional experience. It's actually a learned memory that evolved to keep us alive.
Now for the exam, you absolutely have to nail the distinction between nociceptive and neuropathic pain. Nociceptive pain is caused by actual tissue damage or inflammation in the periphery. Think of a physical injury, like a burn or a sprain. Neuropathic pain, though, is completely different. That results from damage or dysfunction within the nervous system itself, like what you see in diabetic neuropathy. The wires themselves are frayed, so to speak.
But wait, there's a third category you can't forget: nociplastic pain. This is a massive trap on exams. It's when the central nervous system alters its own pain processing, but there is zero evident peripheral tissue damage. The textbook example here is fibromyalgia. There's no active injury, but the pain is absolutely real because the central nervous system's neuroplasticity has shifted.
We also need to classify pain functionally and temporarily. Acute pain is basically your body's short-term alarm system. It's physiologic and protective. It triggers your defense mechanisms. Chronic pain, which we define as persisting more than 2 to 3 months after the initial healing, is a totally different beast. It is a pathological, progressive state. The original injury is gone, but the pain stays and just exhausts the body.
Moving right along to Section 2, Altered Pain and Sensitization.
Okay, do not confuse these two on test day: hyperalgesia and allodynia. Hyperalgesia is an exaggerated response to something that is inherently painful. Imagine taking a hot shower when you have a terrible sunburn. An already painful stimulus is massively amplified. Allodynia, on the other hand, is when a totally harmless, non-noxious touch causes extreme pain. Why? Because the central nervous system has basically failed and can no longer tell the difference between a light touch and a threat.
To really grasp how this happens, just picture the 3-neuron ascending nociceptive relay. First-order neurons go from the periphery to the dorsal horn of the spinal cord. Second-order neurons cross over and head up to the thalamus. And finally, third-order neurons project from the thalamus to the cerebral cortex so you actually consciously feel it. Sensitization can hijack this entire system, disrupting the pathway at the spinal or even the cortical level.
Which brings us perfectly to Section 3, the subjectivity of pain.
There are so many wild factors that modulate how we feel pain. It involves the orbital frontal cortex, epigenetic factors in your sociocultural background. Genetics play a huge role too. For instance, a mutation in the NaV1.7 sodium channels can literally make someone completely unable to feel pain, which is incredibly dangerous. Professor Luongo also highlights gender differences. Females actually have a higher susceptibility to chronic pain conditions, but conversely, they show a much higher pain tolerance in extreme situations, like childbirth.
Because of all this subjectivity, we hit a massive wall in the clinic. There is absolutely no universal objective biomarker for pain. You can't just draw blood and say, your pain is a 7. So we have to rely on the self-reported 0 to 10 numeric rating scale. And as you can imagine, this is super tricky. A stoic patient might call a broken leg a 6, while someone else might call a minor sprain a 15 out of 10. This huge clinical variability makes prescribing heavy-hitting drugs like opioids incredibly complex.
And what if a patient literally cannot tell you a number? For Alzheimer's patients or young kids, we have to use observational tools, like grimace scales. Trying to assess subjective pain in someone who can't communicate is one of the hardest parts of the job. Honestly, this constant diagnostic uncertainty is a major driver of burnout for pain specialists.
Let me ask you something kind of mind-bending. Can changing the spatial representation of your body and your brain actually reduce the pain you feel? It sounds like magic, but it's pure neurology.
Amazingly, the answer is yes.
Professor Luongo brings up a brilliant experiment by Gian Domenico Iannetti at University College London. They found that simply crossing your fingers deceives the brain's spatial processing. By confusing the brain with a spatially unexpected physical setup, it mildly disrupts the pain signals. We call this distraction-induced analgesia, and it just perfectly illustrates how heavily our cognitive interaction modulates physical pain.
All right, let's pull this all together in Section 4, Pathophysiology of Chronic Pain.
Here is a classic exam question you need to be ready for. Why do standard, everyday analgesics like NSAIDs so frequently fail to treat chronic pain states? Think back to your basic pharmacology here.
It comes down to the mechanism. Acute inflammatory pain is driven by peripheral COX enzymes pumping out prostaglandins. NSAIDs work perfectly there. They block COX right at the source. But chronic neuropathic pain is driven by central nerve damage and neuroplasticity. So giving an NSAID for chronic central pain is basically trying to put out a peripheral fire that burned out months ago, completely ignoring the fact that the central alarm system is still blaring away.
And when that central alarm keeps blaring, it kicks off a vicious neuropsychiatric cycle. The constant anticipation of pain creates hypervigilance. That dysregulates the HPA axis, the hypothalamic pituitary adrenal axis, pumping out cortisol and BDNF. This chemical soup literally remodels the neurons in your emotion-regulating circuits, ultimately leading to secondary depression and anhedonia. Chronic pain is physically rewiring the brain, which is exactly why simple painkillers fail and neuromodulators become totally essential.
The absolute textbook clinical example of this for your exam is postherpetic neuralgia, or PHN. After a shingles outbreak, the skin heals, but the nerve damage leaves nearly half of older patients with this agonizing electric shock-type pain. PHN proves that chronic pain is a disease in itself. Because it's neuropathic, you have to make a major pharmacological pivot away from NSAIDs and move to adjuvant drugs like tricyclic antidepressants or anticonvulsants.
Okay, let's bring it home. Section 5. Exam Review, Key Statements.
Here are your top 5 foundational definitions. 1. The IASP definition. Pain has both sensory nociceptive and subjective emotional components. 2. Nociplastic pain is altered CNS processing with zero peripheral damage. 3. Chronic pain persists more than 2 to 3 months after peripheral healing. 4. Allogenia, pain from non-noxious stimuli due to a CNS failure. And 5. Hyperalgesia, amplified sensitivity to an inherently noxious stimulus. Make sure you have those locked down.
And the final 5 heavy hitters. Subjectivity. Pain has no objective biomarker and is heavily swayed by genetics and gender. Cortical modulation. Distraction-induced analgesia shows that spatial representation changes perception. Chronic pathophysiology. HPA axis dysregulation leads to actual neuroremodeling and depression. NSAID failure. Chronic pain is centrally maintained, completely bypassing peripheral COX targets. And finally, the pharmacological shift. Neuropathic pain, like PHN, requires neuromodulators, not your standard analgesics.
I'll leave you with this one last thought to chew on. If chronic pain is basically a learned neurological memory that fundamentally rewires the brain's circuitry through plasticity and HPA dysregulation, what new pharmacological targets might let us actually unteach it one day? Could we figure out how to reverse that neuronal remodeling instead of just masking the signals? Keep that in the back of your mind as you study. Best of luck on Professor Luongo's exam. You are totally going to crush it.